Just two people.
Yeah. Okay.
One actually in the East Coast, right? So basically, welcome guys. This is our first attempt to do online meetings. Today we're going to have Cristina Munoz presenting about automatic detention and PyPi, which is it looks like an amazing topic. She's right now sending us the presentation, and while she does that, I wanted to give you guys a little bit of a FYSA, and basically this is what we're trying to do. The meetings will go online for the next 2 months, and then after that, we're going to evaluate if we can come back to in-person meetings. Most of you know, obviously, what's going on in California, and we're trying to basically sail through this as we go, because the situation is sort of fluid and it changes pretty quick. So we're gonna review then, and then advise if we can come back to in-person meetings. The Bay Area CTF and Chile cook-off that we were going to do in April has been postponed. The new date will be announced once we have an idea of when we can do this event. The meetings will be saved and posted at the YouTube channel that you're looking at there. You just go and since it's a brand new channel, we still don't have our own URL, but you can go in YouTube and type Pacific Hackers, and you will find our channel. You can also join our Slack, which is %-27.slack.com. We have a channel called Current Disaster, where we have a lot of open source intelligence and up-to-date information on what's going on. And we do have different channels for the InfoSec industry and threat intelligence, etc. So if you email me at info@bhack.org, I will definitely add you to the channel. Cristina, you back?
I'm here.
Okay. Did you email me your?
I think I emailed it to Marco.
Okay. Okay, Marco, do you get it?
Yeah, I got it.
Okay, so I'm gonna make you presenter, Marco. Hold on.
Let me open it.
I also opened like a new browser, so I can give it a try here.
Marco, am I making you presenter or?
Let's try Cristina. She wanted to give it a try.
Yeah, I'll just try it right now one more time.
Okay, try it.
Okay, and then if that fails, we'll just have like a Marco, like.
Just make you presenter.
All right. Cool. So I have the window open. Excellent, and I'm gonna share my screen.
Coming up.
Cool. Allow. Okay.
There you go.
Oh, there we go.
Can you guys see my screen?
Yeah.
Yeah.
Awesome.
It's all yours.
Cool. Cool, cool, cool. Let me just get my notes up. All right. So we're going to go on a journey, a narrative journey about automated malware detection in the Python package index. So buckle up. Cool. My name is Cristina. I'm going to start by introducing myself and talking about how I became something of a subject matter expert on this topic. I've spent the better part of the past decade writing software and doing security stuff at tech companies, but only recently have I gotten into security. I've only really been doing it professionally for about 3 years. Most of my work experience has been at big tech companies and consultancies in San Francisco and New York, as well as a brief stint at a research institute in Berlin. I like solving human problems with software tooling. My last gig was at a Google X startup called Chronicle Security, which was formerly acquired by Google Cloud in August 2019. This is 3 months after we brought our flagship product to market. This product was called Backstory. Backstory is a new kind of security information and event management system, also known as a SIEM, which integrates all kind of security-related telemetry like syslog data, EDR, data network information, Active Directory information into one place, and is constantly scanning all of this data looking for indicators of compromise, also IOCs. Security folks love acronyms, so there's a lot of them in this talk. I'll try and define all of them, and if I use an acronym you don't know, please make a note in the chat. The marketing department touted Backstory as kind of a single pane of glass for a SOC. It's integrated with all kinds of threat intel feeds, like the Department of Homeland Security has one that it was integrated with, but a dozen other ones, virus scanners. VirusTotal was actually part of Chronicle Security while we were operating, so deep integration with VirusTotal was part of our product offering. After Chronicle was acquired, I was offered a spot with our googly overlords. But I decided that I was not about that life. So instead, I went on a vision quest in Guatemala. When I was in Guatemala, I was thinking about what I was going to do next with my career, in between swimming in waterfalls and eating tamarindo raspados. I got an email from someone that I've never met before. This person was representing the Python Software Foundation emailing me about an upcoming request for proposal that they had issued. So Samana, like I mentioned, I have never met this person in person, and as it turns out, I have not even chatted with them on Slack, as they suggest in this email. But she found me because we'd both been part of this like pseudo-bohemian programmer retreat known as Reefer Center, formerly Hacker School. She asked me if I had any thoughts about cryptographic signing or malware detection, which was the subject of the RFP, and if so, to consider submitting a proposal. So I received this email on September 3rd. The RFP deadline was October 21st. I finished my vacation and got back to the Bay Area and started looking at this proposal a bit more deeply. So let's talk a little bit about what the Python package index is, because some of you who aren't from the Python ecosystem might be a little confused or unfamiliar with it. The Python package index is the official third-party software repository for Python. So almost every programming language has some kind of official or canonical package source. And the names of these package sources invariably are some kind of acronym that reference the programming language. So for example, Node.js's package archive is called NPM. You can find it at npm.js, and the package manager is also called NPM. Perl has one, it's called CPAN, and for Pythons, it's PyPi. The way that you install software from PyPi is with pip typically. So if you've ever run a command that looks like this, then you've used PyPi, unbeknownst to you. PyPi is critical software in the Python ecosystem. So here's a question. When you install a package from PyPi, the official Python package repository, using pip or some other method, how do you know that the software that you are installing is not malware? And the answer is that you don't. You don't know it's not malware. And the reason that you don't know is because the people that, oh, can someone put their mic on mute? Cool. The reason that you don't know is because the PyPi, administrators don't know. So let's talk a little bit about operating system package repositories. So the Debian package repository, the Debian project, keeps 25,000 packages in their repo for people to download over the Debian package manager, which is called apt. Each of those 25,000 packages, it has been manually reviewed or sponsored by like a Debian core developer. So there's kind of this community of developers that like maintain the security and integrity of this 25,000 package large ecosystem. So PyPi, there are 5,000 file uploads every day to PyPi, and that number is only growing. So 5,000 file uploads a day versus 25,000 packages, like the scale of the problem is just like too large for people to like manually review every single upload that happens. So there's definitely a need to do some kind of automated screening here. Let's talk about the RFP. I also see some questions coming in. Oh, yes, it's being recorded. Cool.
Are you advancing slides? Oh, there we see. I see some now. They weren't advancing before. Thank you.
Yeah, cool. So the RFP has 2 milestones with the overarching purpose of implementing these advanced security features. The first milestone is basically implement the update framework as a way to ensure that the files and the packages that users download haven't been tampered with. So that they're the same files and packages that the developers of these packages are uploading to PyPi. The update framework does a lot of really neat stuff and has been pretty widely adopted at this point by places like Cloudflare, Docker, DigitalOcean, and others. The idea of Milestone 1 is to protect users against compromises of like PyPi mirrors, PyPi's own TLS termination, and content distribution infrastructure. PEP 458 has a lot of details about how it will do that. So if you are interested in learning more about Milestone 1 or the update framework, definitely go check out the update framework documentation or PEP 458. That's pretty much everything I know about Milestone 1 and the update framework. And this talk is actually titled Automated Malware Detection in PyPi. So let's go ahead and talk about Milestone 2, which is what I actually submitted a proposal for. Cool. So in this RFP, the authors describe a system that needs to be extendable and work with open source software development practices. So effectively, we want to crowdsource security. There's also some storage infrastructure that is needed to store information about these malware checks and also the results that these checks generate. These results need to be surfaced to administrators in a view, and there needs to be documentation. So in a sense, what PyPi wants is their own single pane of glass for viewing and investigated security relevant events. Cool. Another perspective on what they want is a SIM, right? They want to collect security relevant telemetry, scan for indicators of compromises with checks, and then extend the system to ingest different like signals, so different threat feeds or different malware signatures. This is a SIM. They want a SIM built into PyPi. I know a couple of things about SIMs. So with no freelance or consulting experience at my back, I dove headfirst into writing what this proposal would be. And much to my surprise, my proposal was selected. This is an email from Ernest, the director of infrastructure for the Python Software Foundation, letting me know that they wanted to implement my design and that I would be working with another security firm to actually implement some of the malware checks that would be hooked into the system. Cool. So, any questions so far? I mean, this is just kind of the story about how this came about. Cool. So let's talk a little bit about packaging.
The people yet, so I'll let you know.
Oh, okay, cool. Awesome. So let's talk a bit about like some packaging concepts because I feel like this audience might be mostly security engineers and maybe not super familiar with like software packaging ecosystem stuff. So fundamentally, there are 3 kinds of assets that we're trying to protect here. Projects, releases, and files. This is a Python package that I actually have developed and maintained that's hosted on PyPi. Right before this call, I looked up how many projects are hosted on PyPi, and as of today, it's 222,580 something projects. A project is the top-level organizational unit for this third-party software hosted on PyPi. Projects have a name, a description, 1 or more authors or maintainers, and most importantly, they contain something called releases. So releases are the next most granular unit in packaging. A release is simply a particular version of a package, and a release contains release files. So here you can see that my SodaPy package contains 2 release files, a wheel file, which is a distribution type, a built distribution, and a source file. When someone installs this package, they will install one of these files to run and execute my package. So when we're talking about malware, the release files are typically the assets that people tend to focus on as I'm going to be talking about a system that operates on all three of these assets. And then right now, we're going to talk about actually different attacks that someone can perform on each of these types of assets. Also, the verdicts that the system generates, or IOCs, depending on like what world you're coming from, will always be associated with exactly one of these assets via like a foreign key relationship. Cool. So the first attack is going to be on package names, so on the package unit. A common tactic used by hackers is to simply create a project with a familiar or legitimate-looking name and hope that someone accidentally installs it, right? So the legitimate dateutil module provides extensions to datetime, which is a Python standard library module. And it's actually already Python 3 compatible, but someone got really clever and decided to create a Python 3 dateutil module. And then Jellyfish is also a legitimate Python module, but this package name is actually Jellyfish spelled with an uppercase L, or an uppercase I and a lowercase l. So it looks like a widely adopted and legitimate package name. What these two packages do is actually steal your SSH and GPG keys when you install them. These packages, dateutil is particularly insidious, or actually, let's go back to these package names. So on December 1st of last year, 2019, a German software developer named Lucas Martini discovered that these libraries were actually malware. He notified the PyPi security team. They investigated it, and the same day they took both of these packages down. So thankfully, Python 3 dateutil was actually only uploaded 2 days before this discovery was made, but the malicious Jellyfish library had actually been live for nearly an entire year, getting dozens of downloads every day from unsuspecting users. The other issue is that the official Debian repository actually does have a legitimate Python module called Python 3 dateutil that users can install. So if for some reason someone wanted to install Python modules from Debian instead of from PyPi, they would actually install something called Python 3 dateutil, which is actually just the legitimate dateutil module built with Python 3. So this was like a really insidious attack that happened just 4 months ago. This actually happened while I was working on this malware detection system. So these typo squatted and name squatted malicious packages are cropping up all the time. All right. I also want to talk a little bit about kind of creative mitigations people are taking against typo squatting and name squatting. So you can't really apply like something like an edit distance filter for packages that have a small edit distance away from, legitimate package names, because you're going to generate a lot of verdicts if you do that. There are literally thousands of projects that have similar names. So a more fine-grained heuristic would be required to really address this problem effectively. But an even more clever thing that people are doing, like the PyPi security team, and also like independent security research firms, is to preemptively name squat packages that are like potentially typo squatted or other package names that might be susceptible to abuse. So by preemptive name squatting, I mean they just legitimately register empty projects with misspelled names or names that are like prepended with Python dash or like Python 3 dash. So that's pretty cool. All right, let's talk a bit about setup.py. So as I mentioned earlier, there are two principal package distribution formats for Python: build distributions and sort distributions. Wheel is an example of a build distribution. Build distributions are exactly what they sound like. You install them on your system. They're already built. When you install them, you basically just download an archive file, and then the package manager that you're using moves the built files into the right locations so that when you call them, they're executed. They don't execute any additional code on your system. And are generally like the more modern, newer, preferred packaging format for package developers. An older distribution format is source distributions, and they actually do require an extra build step on the user environment after they're downloaded, which the developer of the package actually controls. So I'm developing a package, I want to put some malware in it, I can actually just inject it into the setup.py file, which is required for source distribution. Setup.py is the build instructions that are executed on the target machine. So this is an insidious attack vector because it's basically giving developers of packages like a backdoor for remote code execution on whoever downloads their packages machines, and like just on the install. So when someone does pip install whatever, when that install operation happens, me as the package developer can just run whatever kind of command I want if I hook in this install command. So here I've hooked in the install command, this post install class. And then in this post install class, I'm running a reverse shell and then installing my malware. And this is like something that package developers have control over and a way for them to like remotely execute code on your machine. So like I mentioned, Wheel kind of mitigates this attack path, but a lot of package maintainers are still uploading packages with source distributions that execute arbitrary code on install. Cool. So the last thing I talked about is how to compromise the actual release files. The final attack path I'll talk about is compromising releases themselves. So this is a story actually from another programming ecosystem. This is from the Node ecosystem, but it doesn't mean that it can't happen in the Python ecosystem. So let's consider a not so hypothetical scenario. A busy software engineer, not so hypothetically called Dominic Tarr, is approached by a seemingly legit developer, not so hypothetically called Right9 Control. And the seemingly legit developer offers to take over a somewhat popular package for the busy package maintainer. This package is called Event Stream. Ownership of the package is transferred. The new owner pushes the new release to the package. This new release contains malware. Thousands are affected, chaos alarm, and this really depressing GitHub issue ensues. Owners and maintainers of open source packages are an extremely porous attack surface. And even if an owner doesn't like voluntarily cede control of their package to someone they've never met before, there are other ways that people can attack package maintainers. So for example, PyPi only enabled two-factor authentication in June of last year. So two-factor authentication has only been possible to turn on for about 9 months at this point, and it's not required. So package maintainers that don't have this turned on are still susceptible to things like credential stuffing attacks or brute force password attacks. Just because it hasn't happened yet doesn't mean it won't. Malware. There's malware everywhere. And I also don't want to disparage, just really quickly, too much.
Cristina, we have a question. Can these malware packages also found with OSS?
Okay, so PyPi only hosts open source software. So yes, I'm only talking about open source software right now. Okay, so I don't want to disparage the hardworking army of almost entirely volunteers trying to keep PyPi users safe. There's a lot of hard work going into manually screening PyPi packages for malware, but there's just so many threat vectors out there and so much malware out there, most of which we probably don't even know about, that there really is a need for like some kind of automation here. Cool. So when I was putting together this proposal, I had to roll up my sleeves and do some web application development. I haven't done web app development in a really long time, so I had to kind of like re-familiarize myself with like web app architecture. And I'll just kind of give a little bit of the overview of the architecture of the software that powers PyPi, which is called Warehouse. So Warehouse is also kind of new software. It was rolled out as the PyPi backend in April 2018. It was written from the ground up. It uses Pyramid, which is a Python web framework, SQL Alchemy as the ORM, or database abstraction layer. The backend is Postgres. Front end uses Jinja 2 templates, pretty standard. And then if you're developing locally, Docker Compose can be used to bring up like a bunch of different Docker containers and manages like the connections between those containers. Warehouse also is integrated with Celery. Celery is a distributed task queue implementation for Python web apps used for asynchronously executing like long-running processes or things like batch jobs. So this is like the web app that our sim has to live in. So going back to these types of checks, when I'm thinking about like the elements of my proposal and like these different attack vectors, I kind of see two patterns emerging. Like there are two places where we want to be looking for suspicious activity. One is on like discrete singular events. So when like files are uploaded or new projects are created. And the other is kind of like a more broad, high context, like sequence of behaviors or like patterns. So for example, a maintainer transfers ownership of a package to a low reputation user whose IP address is coming from like a VPN and whose account was created like in the last 24 hours, right? None of these events in isolation is particularly suspicious, but like given all of these facts and all of the context surrounding like this package transfer of ownership, this is maybe something that we would want to like raise an alert for. So yeah, there are two kinds of checks that the system needs to support. It needs to support hooks into events that happen, which are events that happen like at discrete times, and then it also needs to like be able to look at patterns and behaviors and do these kind of investigations in like a scheduled way. Cool. So event-based checks are useful, like I said, for low context heuristics for identifying malware. For example, as soon as a file is uploaded, you could do something like send that file to VirusTotal to run it against a few different antivirus engines and then see if any of them report that file as malware. You could also write some YARA rules to look for malicious code signatures. Upload time is also a good time to do things like running static or dynamic analyzers. What kind of tracking is used for hash values of submitted files? So right now, I'm going to get into some of the checks that are already instrumented. But by hash values, presumably you mean like just like an MD5 of files, or like, yeah. So when the files are uploaded, they are, you know, like an MD5 and a SHA-256 is computed, and that's used actually as like the primary key in the warehouse backend for those files. But we're not submitting those file hashes to VirusTotal yet. Cool. So yeah, at upload time, there's a number of things you can do to a file or a project or a release, a number of scans or checks that you could run to figure out if something fishy is happening. And one of those scans that we actually rolled out the system with is actually a couple of different YARA rules. So right now we have some YARA rules that are instrumented to look for sketchy things in the setup.py file. Some of the sketchy things we're looking for are new processes being spawned, like the subprocess module being imported, for example, or people running like exec or evaluation statements. Making network calls, like a call to a command and control server is like a pretty classic malware move. So we're looking for like outbound network calls. Deserialization refers to serialized or obfuscated code that could contain like a malicious payload. So a lazy hacker might base64 encode like a reverse shell in setup.py. So if there's any importing of like pickling or base64 decoding in setup.py, like we're raising alarm bells for that. And then metaprogramming. So metaprogramming is like another obfuscation strategy that hackers use to access Python internals without actually referencing like literal strings like exec or eval. So the first bullet point is actually matching literal strings like exec or eval, and then the last bullet point is looking for things that are the libraries that are importing that functionality and see if that's getting called. The bad news about this approach is that it's always going to be an arms race. So you can only put malware signature or like a string match into a YARA role like once you've already identified that as a way that hackers are using to like inject malware into setup.py. And there's also a lot of legitimate reasons someone would want to spawn a process or make a network call in setup.py. So one example is we turned the system on in the test PyPi server, which is found at test.pypi.org. And PsychoPG, which is actually like the official Python client library for Postgres, like raised a verdict because it does this like subprocess spawning when you install it. Let's see. Oh, there's also a lot of Python packages that like install random third-party software when you download them, which like as a security person to me sounds like malware, but you know, there are a lot of legit users that legitimately rely on this functionality. So like if you're installing some kind of DevOps software and you know, someone in their setup file is downloading like other software with their Python package, pip will be like, okay, I'll install this package, but the developer also wants me to install Terraform and download that. So like, I'm gonna go download Terraform now. So this just generated like a ton of verdicts when we enabled it. And like, we need to really hone what these YAR rules are and fine tune them so that we get like a better signal to noise ratio. Cool. Schedule checks. So schedule checks are useful for analyzing things where we need like a lot of context surrounding certain behaviors to be able to make a determination about whether something could be potentially malicious or not. So you would use a schedule check to like determine if a sequence of actions is suspicious. So like an example of some suspicious actions would be like a low reputation user with a recently created user account and a sketchy IP address creates a package name with that is one character edit distance away from a very popular package name, or the maintainer of a popular package disables two-factor authentication and then transfers the ownership of his popular package to another user. There are a lot of these kind of like reputation-based checks that we could integrate, but so far the only check that we have integrated for user behavior, which is actually like a higher signal than the YAR rule, is using the package turnover as the heuristic. So this is implemented algorithmically. It basically just queries the warehouse database to look for new releases every 24 hours, and then further queries those releases and the packages associated with them to look for like maintainership transfers or package ownership changes in the past 24 hours. All right. Cool. So we've talked a little bit about the types of checks that are implemented and are running. Let's talk a little bit about the infrastructure and actually how they're running. So either an event happens, like a new project or release file is created, or it's noon on a Monday, so it's like a schedule thing, or the system even has the capability for an administrator to press a button and manually trigger a run of a particular check. The check run happens, it populates a new table in the warehouse database called verdicts. There's an administrator view that reads from this verdicts table and surfaces these verdicts for manual review. And then this admin can just kind of like look at this window and go down the list and investigate the verdicts. They can either mark those verdicts as benign, and they kind of like are eliminated from this view or triaged, or if their investigation yields that a verdict is legitimate, they can then like take further actions, like contact a package manager or take down a malicious package. So here I have just kind of like in black text check runs. So let's actually investigate more like what that entails. So the mechanics of a check run for hooked checks involve hooking into the SQL Alchemy database session and listening for object creation events. So whenever an object is created in the session, a database query is kicked off that then looks for checks that operate on that associated object. And then it queues up all of those checks for the object, runs them in like this distributed asynchronous way, which populates the verdicts table, and then those verdicts are surfaced to the admin. Let's see. Cool. Olga, can you mute your mic? Can I mute Olga?
Who's ready to see Serena?
We should be able to.
Okay, cool. Awesome, thank you. So this is how the celery task queue works. Developing new checks. So you are a software developer or a security engineer. You want to improve the security of PyPi. You too can contribute checks. All of this stuff is open source and it's well documented. So you just download the warehouse code base, bring everything up with Docker. When you go to develop your new check, there's actually a base class that you can just inherit from. And writing a check is as easy as just implementing a method in this base class. Then to enable this check, you have to toggle like an environment variable, because by default in your development environment, these malware checks won't run. They'll actually just print the information about the check anytime like a hook happens. So just toggle this environment variable to actually run the checks. There's a script that you can then use to deploy your check to the database. And then when you actually bring up the app, you can just log into the app admin to enable it, and then perform whatever kind of event is required to actually trigger your check. So this is kind of the life cycle for if you're a developer and you want to contribute this malware check, how it will work for you. The first thing you should do is actually open a GitHub issue. So you let the PyPi admins and then like the broader Python community know that like you want to implement a malware check and get feedback from them about that check. If the feedback is good and people are excited about your proposed check, you can go ahead and open a pull request on GitHub. When the admins have a chance to review your pull request, they'll deploy it probably to the test PyPi instance first and then to production. After they deploy it, they'll enable it, do an evaluation run, review the verdicts, make sure there's a good signal-to-noise ratio, and then either give you feedback about improving the signal-to-noise ratio and tuning the check, leave it as is, or if they decide that it's just like really noisy and not useful, there's the capability to wipe out the check or revert it. So I don't know if this will work, but we'll go ahead and give this a try. We should be able to log into the test admin and like actually see the views that I developed. Maybe not though. Just a second. No, I think I have to share a new window. Just a sec.
We actually have two really good questions on the chat. So while you're doing, you're trying to share the other screen, go ahead. So you can answer those questions actually.
Yeah, can you read them to me actually?
Yeah, so the first one from Rasa, it's what kind of check is used to already popular files with an owner that may have gone rogue or had their account compromised? And then as a secondary question there is, are files immediately deleted or placed in a quarantine or sort?
Yeah, so I'll answer the second question first. There's no kind of like automated actions happening as a result of these checks running and the verdicts being generated. An administrator has to manually review the verdict and then review like the package or the release file or whatever the verdict is associated with to actually confirm that it's malware. And then the administrator at that point can decide what subsequent actions to take. So that could be taking down the package if it's determined to be malicious. It can be reaching out to the package maintainer if there's like something fishy going on with their user account. But right now, there's no automated stuff happening beyond the check running and the verdict being generated. What kind of check is used for already popular files with an owner that may have gone rogue? Okay, so right now, the only two checks that we have instrumented are the ones that I described. So I think like a really good check to be implemented that I really wanted to have rolled out when we first rolled out the system, but like we just kind of ran out of time and money. So if someone in the open source community wants to contribute this, that would be great, is uploading checks to VirusTotal. I think getting the detections from VirusTotal would be like a really useful signal for determining if there's like something that's known malware is in a package. Or if they had their account compromised. So if they had their account compromised, they could hopefully reach out to the PyPi security team to let them know their account's been compromised. Or the package ownership check actually looks for like suspicious behavior around transferring package ownership to newly created users. So there is something in place for that. And then that looks like.
That's another. That's one question. The other question is from Ray. Is there a way for end users of a package to report suspicious behavior of a downloaded library, so you could sort of have a community rating for the downloaded package? I think you answered that, but go ahead.
Yeah, I think that is actually like a really great. So did I stop screen sharing? Or can I stop?
You're still on.
Okay, cool. I'm going to share the other screen because I got this worked out. Let's see. This one. Allow. All right. Can you guys see that screen now?
Yes.
Awesome. Okay, so I'll answer this other question and then we'll do a tour of the admin. There currently is a way for end users to report, like, security vulnerabilities to PyPi or packages that they think are suspicious, and that's just to reach out to the PyPi security team. I think it's just security@PyPi, or security@Python. You can look this up, if you give me a couple of minutes, I can find the right email alias for you. But there is a team of mostly volunteers dedicated to receiving these inbound requests and triaging them. So for community ratings, there is something called source rank, which I recommend that you check out. One of the ideas I had for malware checks that, again, has not been implemented yet because it's a really new system, would be integrating that kind of signal, like reputation information from source rank, and then using it to raise verdicts based on suspicious behavior. So that would be like an example of like a high context, probably a scheduled check. How about creating a virtual environment that does code coverage analysis? Yeah, static and dynamic analysis would be great checks to integrate. And I encourage you all to go out and write these checks because we need that. Cool. Oh, and looks like Ernest is actually here. Thanks, Ernest. There's a lot of people on this call that probably know more about Python packaging ecosystem and security than I do. So maybe when I'm done showcasing this UI, we can cede the floor to them for a few seconds to add anything that I missed or like provide a different perspective. Cool. So this is what the UI looks like. There are 2 new sections added to the warehouse admin that I added as part of this work. One is the check administration interface, and this is where admins can go to do things like turn on checks or run evaluations when a new check is becoming enabled. So this is an example of a scheduled check. You get information about which version of this particular check it is, what the schedule it runs on is. Looks like this is a check that runs every day at midnight and when it was created. This check is enabled, which means I can do things like manually trigger an evaluation. But if we decide that this check isn't useful, we can move it to wiped out, for example. When new checks are first deployed, though, they are automatically in the disabled state. The other interface is this verdicts admin. And this is with all of like the IOCs basically from these checks. So most of these are coming from the YAR rules check, which is the setup patterns check. You can go ahead and investigate this fanficFair object to see why this verdict was raised. And in the message, you actually get the information that there's a process spawn in setup, and then information about where this process spawn is happening. If I then were an admin and I were to manually go investigate what's going on with this package, I could do things like see who uploaded it, take a look at what it looks like from the user perspective. If I were to download this package, download it myself and like manually inspect the source code. And then once I take these actions, go ahead and decide that this is actually fine. There's nothing wrong with this, or if there's something is wrong, flag it as a threat. And then it is removed from the default view, which shows us only verdicts that need to be reviewed. Cool. So I think I already, unfortunately, closed out of my presentation, but I have a couple more slides. Let me see if I can go back to that.
And we have one more question from PXMX. Do the check have any sort of priority confidence? For example, check A might be higher confidence than check B, so the admins will review results from check A first.
Yeah. So, and then never mind, I see confidence. So that the confidence isn't what you think it is, unfortunately. Hold on a sec. This thing. Cool. So yeah, the confidence and the classification are flags that the check developers actually instrument, not the admins. So the person who's contributing the check is supposed to be providing the signal for how high confidence or high fidelity they think that check is. And I think that that is actually a weakness of the system. I think there, over time, and again, this is a new system, but I think there needs to be a way to kind of do like a meta-analysis of all of these verdicts and actually see which verdicts from which checks were actually surfacing like legitimate threats versus which ones were noisy, and then adjust those values accordingly. But right now, those values are set just by the check developer. So for the YARA rules check, for example, if like in setup.py, someone is importing the OS module, I think that that is set as like a low confidence, low fidelity indicator. But if someone is importing like the subprocess module, the developer decided that that would be like a high confidence, high fidelity indicator. Cool. So do you guys see my presentation again?
No, go ahead, I guess, unshare and then share again, see if it allows you.
Okay. Let's see. Allow.
There we go.
Awesome. Cool. So everything I talked about is actually documented in the warehouse docs, everything except the Guatemala vacation stuff at the beginning. So go ahead and check that out. All of this code was finally merged a couple of weeks ago in one massive pull request of 4,000 lines. We wrote a sim and integrated in a PyPi in 4,000 lines of code, which leads me to some alternative title slides for this talk: how to build a custom sim in 4,174 lines of code or less, or how to quit your big tech startup and bootstrap your own startup. So yeah, if you guys have any more questions or comments, or questions for other people that know more about the Python packaging ecosystem or Python security than I do, now's the time to ask those.
Cool. There's a few questions coming up. So can checks have dependencies on other checks? For example, check A won't issue a verdict unless check B also issues a verdict.
Let me think about that. I don't see why not. Yeah, I mean, so the checks aren't, the checks are literally built into the warehouse code base, so they have access to the whole warehouse database. So they could literally just query the database for like other check verdicts and then decide to issue a verdict based on existing verdicts. Like that is within the capability of the system.
I don't see any other questions. So far, great presentation. I like it.
It's pretty amazing, Cristina. Thank you very much.
Thanks. Yeah, I was actually supposed to be giving this chat at PyCon this year. Now that coronavirus is happening, I don't know if I will be able to do that. So I'm really grateful for the opportunity to be able to talk about the system here.
That's awesome. We're gonna publish it on the YouTube, and if you share your I think Michael has it. We can publish it with it as well. Anybody has any comments or questions? Let me just share this for just a second. Just want to remind people. Yeah.
Yeah, so if people want the GitHub repo URL, I will just go ahead and paste that into the channel. Cool. So like I said, this is all just right in the warehouse code base. So if you go to github.com/, Python Packaging Authority is what PyPi stands for, /warehouse. That's where you can download all the warehouse code base and also get links to the warehouse documentation. And all of the malware check stuff is in just a subdirectory of the main root directory. So it's in the /warehouse/malware directory. Yes, there is literally a directory in the warehouse code base titled malware.
Thank you very much. And before we go, a reminder for everybody, here you can check this presentation. We'll post it in the YouTube channel. There's our email if you want to communicate with us. There's our Slack. Send me an email to info@phack.org, and so we can keep the conversation going. The next meeting we'll be announcing soon, because in our schedule we have the Bay Area CTF and Chili Cook-Off, which has been postponed. But we will have content for our next meeting, and we'll be publishing soon. So thank you very much for attending today.
Yeah, actually, before you leave, Cristina, so we have this conversation at B-Sides, and now you got me into it. So for the people who doesn't know, the presentation was given on an open source laptop, and this is the first time I hear about open source laptops. So can you share the website where you bought the your laptop, and tell us more about it? Tell us how it works and stuff like that.
Okay, I don't actually know everything about this laptop, but yeah, so this was like kind of my first foray, this contract into like getting paid to do open source work. And in addition to getting paid to do this work, which I think is like an incredible privilege, I also want to like give back to this community, because I really believe like in the mission of open source, and it just powers like so much of the software that like we use all the time every day, that it is what facilitates like the world that we live in now. So I wanted to give some of that money back to other open source organizations, which is why I bought this laptop. It's a Purism laptop. I believe the URL is just like puri.sm, like Purism. And all of the software and hardware components on this laptop are like fully like open source and hackable. So yeah, there's nothing proprietary running on this laptop or installed on this laptop, which is pretty great.
How about the performance? I mean, you know, comparing like to commercial computers, I mean, what are your feedback about that?
I would say that this is definitely a hacker laptop. Like this is like, you know, Purism is like kind of a new company too, so they just started making these laptops in like the past few years. And there's still some bugs like that they're ironing out, but if you're like comfortable running Linux and like administering your own Linux environment, like definitely consider getting a Purism laptop.
Awesome.
Cool. I don't see any other questions. Oh, someone asked if we can connect over LinkedIn. I'm sorry, I'm not on LinkedIn. You can email me. What model is them? Oh yeah, it's the Librem 13 version 4.
Awesome. Oh, that's great. Well, thank you so much. I was very happy to, you know, I saw part of the presentation before, I guess, because you gave me the overview and we work on it, and I knew it was going to be a great presentation, but definitely went above and beyond my expectations. So great job. I like it.
Yeah, and thanks you guys. Stay safe out there. And I will see you at another PHAC event.
All right. Thank you very much, everybody.
Bye.
So see you later, guys. Stay safe.